In this section, we're going to talk about the first law of thermodynamics for a closed system. Mainly, the first law of thermodynamics is just an energy balance that relates the change of energy of the system with the heat transfer and work. So if we have a system at state 1 and due to some interaction with the surrounding, it now become at state 2. So how the system will interact? By heat and by work with the surrounding. So this is the system at state 1. It has an energy 1, and due to some interaction by heat transfer or by work, it is now at state 2, which has energy 2. So the first law of thermodynamics relates the change of energy with heat and work by the change of energy of the system from 1 to 2. It is equal to Q from 1 to 2 minus the work from 1 to 2. Here we have the minus sign, since the work here is work done by the system. The positive work is the work done by the system. And mainly the work done by the system has a decreasing effect on the energy. So the work done by the system will decrease the energy of the system. So that's why we have the minus sign, minus work. However, the work done on the system will increase the energy of the system. And since the work done on the system is negative, so we'll have a minus sign and overall a plus sign. So, for example, if the system at state 1 has an energy 1 of 3 kilojoule, and by interaction with the surrounding, it now has some energy E2. Let's say that the heat transfer into the system is 2 kilojoule, and the work is done by the system, which is by the system plus 3 kilojoule. So here work done by the system, and here is heat is transferred to the system. So what is E2? We will say that change of energy E2 minus E1 is Q minus W. So E2 will be equal to 2 minus 3 plus 3. So it will be 2 kilojoule. Okay. So we can say now that the change of energy of the system will be the change of potential energy plus the change of kinetic energy plus the change in internal energy will be Q minus W. Also, we can write the first law of thermodynamics in rate form. So per unit time, you can say that dE over dt, change of energy of the system, is Q dot heat rate minus the power, the work rate. So dE over dt is just d kinetic energy over dt plus d potential energy over dt plus d of internal energy over dt, and will be equal to Q dot minus W dot. If the system is steady, or we have steady state, if you remember, the word steady state means there is no variation with respect to time. So dE over d time will be equal to 0, and we will be left with Q dot equal to W dot.